Let's turn that into examples and do one at a time. So first, these are the four major algebra things that we have to do. Well, the three major algebra things, and then I combine them. So if you have just a polynomial, I'm going to have to use FOIL. This is the reason why it's good to use this definition. This one is going to be fractions, so I'm going to have to get a common denominator. This one's going to be square root, so I'm going to have to conjugate and get rid of the h on the top. And then this one's mixing 2 and 3. How do we do polynomials? F prime of a for any point, or x, is going to be, by definition, the limit as h approaches 0 of f of a plus h minus f of a over h. I regurgitate as a mantra the definition of derivative. Then I put the function in there. If you want, cooking with calculus, we want to do a plus h squared is going to be a squared plus 2ah plus h squared. I'm cooking up what this is. So this is going to be that a... Oh, there's the cardinal sin. Limit means limit. Don't drop your limit sign. Limit as h approaches 0 of, now what? This a squared plus 2ah plus h squared plus 1 minus a squared plus 1 f of a plus h minus f of a over h. The real game here is pull an h out of the top. How do you pull an h out of the top out of each of these expressions? Here, you FOIL everything out, and anything, the minus goes onto both. Remember, I'm lazy, but cancel, 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 cancel. Anything without an h in it should cancel. What does that leave me now? That leaves me the limit as h approaches 0 of 2ah plus h squared over h. Be careful, don't just cancel like that. Take the h out. The limit as h approaches 0 of h times 2a plus h over h. Cancel, cancel. And then now this is the limit as h approaches 0 of 2a plus h. There's no discontinuity anymore, so I can write this as 2a. Let's do the next one. Alright, so the next one we're going to do is plus 1 cat, a fractional expression. So what do we have to do? We have to get a common denominator. What are we really trying to do? Get h out of the numerator. So f prime of a is equal to the limit as h approaches 0 of f of a plus h minus f of a over h. I regurgitate the definition, and then I put in the moving parts. This time, f of a plus h is going to be 1 over a plus h plus 1. F of a is going to be 1 over a plus 1. So now here, I also know that dividing by 2 is the same thing as multiplying by 1/2. So I'm going to write this as the limit as h approaches 0 of 1 over h. Because I have a fraction, I'm going to leave it on the outside. If you do everything right, the whole point is to get an h out of the numerator. So I have this guy, 1 over a plus h plus 1. Notice how I left it space minus 1 over a plus 1. This one is missing a plus 1. So I'm going to cleverly multiply by 1. This one is missing a plus h plus 1. I need to get a common denominator because I'm adding fractions. It doesn't matter what it looks like, the rule is the same. Now I have a common denominator, and I guarantee anything without an h on the top will cancel out. So this will give me the limit as h approaches 0 of, what do I have? On the top I have a plus h minus a minus h minus 1 over h times a plus 1 times a plus h plus 1. Cancel. Cancel, cancel, cancel. This is equal to the limit as h approaches 0 now of negative h over h times a plus 1 times a plus h plus 1. Now the h's cancel. This is the limit as h approaches 0 of negative 1 over a plus 1 times a plus h plus 1. Now there's no problem. H can go to 0. This goes to negative 1 over a plus 1 times a plus 1, which is a plus 1 squared. You'll have to practice cleaning them up a little bit, but next. The third one is now a radical. How am I going to get an h out of the top? I'm probably going to conjugate that. Will get rid of the square roots. Quickly, what I'm using is every time you have a minus b, that's cleverly a to the 1/2 squared minus b to the 1/2 squared. Assuming they're both positive, but whatever. And then what do I have? A minus b root, square root, 1/2, root a plus root b. So do you notice, and then these are usually integers which aren't perfect squares, so those are irrational. So what they want to say when we want to rationalize the numerator, etc., is these will be rational numbers and these are irrational. So if I have, which is what we're about to create, a square root minus a square root, what do I have to do to get no square roots? I have to multiply by the same thing but with a different sign in the middle, which is called the conjugate. So this is the move I'm about to make. And I use a and b specifically because the b is going to now be a and the a will be a plus h. I'm going to change what it looks like, but the rule's the same. The rule's the same. F prime of a is equal to the limit as h approaches 0 of f of a plus h minus f of a over h, which now this one is going to be what? F of a plus h is equal to the square root of a plus h plus 1. F of a is equal to the square root of a plus 1. I put that into my definition now. This is the limit as h approaches 0 of the square root of a plus h plus 1 minus the square root of a plus 1 over h. And now it's exactly, I have my square root minus the square root. How do I get rid of that? I multiply by the exact same thing, but with a different sign in the middle. But that's crazy. So I multiply by 1 in the form. You're not getting rid of it, you're moving it to from the numerator to the denominator. And what did that do to the top? That did in the formula a square root minus a square root. When you multiply those, it'll be the first thing without a square root minus the second thing without a square root. So this is the limit as h approaches 0 of a plus h plus 1 minus a plus 1 over h times the square root of a plus h plus 1 plus the square root of a plus 1. And then anything without an h will cancel off as guaranteed. This is equal to the limit as h approaches 0 of h over h times the square root of a plus h plus 1 plus the square root of a plus 1. And now the h cancels. We get the limit as h approaches 0 of 1 over the square root of a plus h plus 1 plus the square root of a plus 1. Now the h isn't a problem. This equals 1 over something plus something is 2 somethings when the h is gone. The last one will combine these two. We have a fraction and we have a radical, so I'm going to have to get a common denominator and then conjugate the radical. Both moves. What do I have? F prime of a is equal to the limit as h approaches 0 of f of a plus h minus f of a over h. I regurgitate the definition. I put these values in for this expression specifically, which is a tongue twister, which I had to do more than one take of, which is the square root of a plus h plus 1. And that's f of a plus h, and then I also need 1 over the square root of a plus 1. Now that I can see that those are the pieces I need, I can put that in here. This is the limit as h approaches 0 of, because I have these fractions and a conjugate, I'm going to leave the 1 over h out, because if you're doing this correctly, the real game is get an h out of the top, get an h out of the top, which we're about to do. We have 1 over the square root of a plus h. This is going to get crazy. It's going to a plus h plus 1, a plus h plus 1, minus, let's leave a space, minus 1 over the square root of a plus 1. Leave a space. So this one is missing the square root of a plus 1. So I multiply by 1 here. And then this one is missing this guy. So I do the square root of a plus h plus 1 over the square root of a plus h plus 1. Now I have a common denominator. Let's clean that up. This is equal to the limit as h approaches 0 of 1 over h times the square root of a plus 1 minus the square root of a plus h plus 1 over now the square root of a plus 1, the square root of a plus h plus 1. And now I'm going to have to conjugate. So we're going to multiply by the square root of a plus 1 plus the square root of a plus h plus 1 over the square root of a plus 1 plus the square root of a plus h plus 1. You don't have to say it every time. I got the microphone. And now what does that do? On the top, whatever's in the first one minus whatever's in the second one, that's why we did it, equals the limit as h approaches 0 of 1 over h times a plus h, or a plus 1 minus a minus h minus 1 over the square root of a plus 1, the square root of a plus h plus 1 times the square root of a plus 1 plus the square root of a plus h plus 1. Nobody said it would look nice, I just said I could do it. Close bracket. Cancel, 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 cancel. Everything without an h, let's go. And then I'm not rewriting. Oh, yes, I have to get the video. The limit as h approaches 0 of 1 over h times, the square root of a plus 1 times the square root of a plus h plus 1 times that junk. Cancel, cancel. I ran out of real estate. I'll write it out here. Equals, I've done this before, don't skip steps on your homework. This is equal to the limit as h approaches 0 of -1 over the square root of a plus h, the square root of a plus h plus 1 times the square root of a plus 1 plus the square root of a plus h plus 1. Now the h's can go to 0, so this is going to go away and this will go away. So what do I have? Root of something times root of something is just a plus 1, and then I have 2 of them to the square root, so this is -1 over 2, a plus 1 to the 3 over 2. Once you know the rules, on the final exam or something, when they make you do this, use the formulas to check that the derivative of this thing actually is this thing. I'll see you next time.